Hello, everyone. I'm Dr. Xinxin Fan, head of cryptography at IoTeX. IoTeX is a Silicon Valley startup focused on building the next generation blockchain platform for the Internet of Trust Things. Before I talk about the Pebble tracker, let's have a quick recap about decentralized identifiers and verifiable credentials. What is a decentralized identifier? Actually, it's a new type of identifier for verifiable self-sovereign digital identities, which can be used for the individuals, organizations, and the Internet of Things. This specification is currently actively developing by the W3C Decentralized Identifier Working Group. DID or decentralized identifiers represent only the base layer of the decentralized identity infrastructure and do not actually provide the meaningful identity attributes. Decentralized identifiers have the following important properties. First one is decentralized, which means DIDs are designed to function without a centralized registration authority, which can be registered in the blockchain or other decentralized network. DID also is cryptographically verifiable, which means DID are designed to be associated with a pair of cryptography keys. And the owner of DID can use those keys to prove ownership of this identity. The third property is non-reasonable, which means DID should be permanent, persistent, and non-reasonable. The last one is that DID is resolvable, which means DID is useful through resolution. What a DID looks like? From this figure, you can see it starts as a three-letter DID, which is fixed. Also, we have the DID method, which is followed after that colon. In this case, it's SOV. This is called the DID method, which specifies how a DID is created, read, updated, or deleted. Basically, provide you how to do the CRUD operations on the DID. After that DID method, we have the method specific identifier, which is alphanumeric strings that is guaranteed to be unique within the context of the DID method. Many blockchain projects provide the DID method, which also registered on the W3C website. From this table, I list a few of them. IoTeX is also one of them. It's a start from the DID :IO:. So you can check our GitHub website to see how the different methods are being defined. In order to resolve a DID, basically we need to resolve that string and map to a DID documents. So DID infrastructure acts functionally as a global decentralized key value store, where the DID will be your keys and the documents, DID documents are the values. Some projects also provide a universal resolver. You can check from this website. Basically, they provide a universal API that works with all DID methods, which means if you write a driver for this universal resolver, and from here, people can access through those APIs to access your DID method. So they try to include as many DID platform as possible. DID documents actually is a JSON LD document containing 6 optional components. You can see from the left side, the first one will be the ID. It's a DID. Okay. The second component is a public key, which shows exactly which public key can be used associated with this DID. Also, the following components is authentication, which specify which authentication method will be used to verify these DID documents. The service component provide you a service endpoint in order to access the service behind this DID. Also, the create or update this field tell you when this DID document is created and updated. The last one is the proof, which basically is a signature about this DID documents, who has signed this signature with which key. Okay, so this is basically the structure of the DID documents. For the verifiable credential, they have the similar JSON LD document structure as shown in the left figure. Basically, the verifiable credential is a attestation for the claim in this document. So all the claims, for example, what's your name, what's your address, which will be used to create verifiable credentials by the credential issuer. So those verifiable credentials are decentralized, also conceptual. So the credential issuers will decide which claim containing the credentials. In this example, you can see I have the name and address. This information is a part of the claim. Okay, it's up to the verifier to make their own decision about whether this credential can be accepted. So in this case, the verifier does not need to contact the issuer in order to verify the credentials someone present to them. Credential holders, on the other hand, they are free to choose which credentials to carry. They may collect many verifiable credentials from the different issuers, and they will decide which credentials to carry and which information they would like to disclose during the interaction with a service provider. What is actually a Pebble tracker? So Pebble tracker, actually you can see here from the figure, it's a out-of-box, trust the smart GPS tracker prototyping kit with 4G connectivity and sensor technology. This one is collaborative development between IoTeX and the Nordic Semiconductors. So IoTeX actually, we built this tracker using the latest cellular chip from the Nordic. This cellular chip support both LTE-M and NB-IoT in these frequency bands. And they also support worldwide operations with a IoT SIM card. So we add the environmental and the motion sensors on this board in order to collect all the sensor information. So this platform also provides very high security using trust zone and crypto cell technologies. The SDK for this development tools are open source. It's from the Nordic, and we add further functionalities based on this SDK. When we build the decentralized data authorization proof of concept, the high-level architecture is like this. We have a Pebble tracker, which will use LTE-M to communicate with cloud backend through the MQTT protocol. We have two parties. One is the device owner, and the other one is the data requester. Basically, the data requester want to access data collected by the data owner. So all those interactions will go through the IoTeX blockchain. Actually, when we implement all those components, we use a combination of the cloud and the blockchain. So in terms of the data collection, actually it's very, very simple. The Pebble tracker will send the data it collected through the MQTT protocols to a AWS IoT core. So after that, the AWS, we use the AWS Kinesis Firehorse, this service, to persist the streaming data to the AWS3 bucket. So yeah, in this way, we finish the collection for the raw data from the tracker, which include the location as well as other sensor data. In order to visualize the data we collected, we need to create a dashboard to visualize all the GPS coordinates on the Google map, as well as the sensor data. So in this architecture, we use the AWS Kinesis data stream to decouple the processing logic from the data injection. We also use the AWS Lambda function to update InfluxDB, which is a time series database for the new tracker data. Each time they collect the time series data, will be committed to this InfluxDB by the AWS Lambda function. We also use the Grafana as a time series visualization tools for building dashboard. So in our system, we have the device banding protocols, which will band the device with their owner. After the device banding protocols have been successfully performed, our account management system will issue verifiable credentials for the device, which basically show which owner own which device. Here, we also use the AWS Lambda function to generate a verifiable credential to attest the device ownership. After receiving the verifiable credentials, the user can register the device on the IoTeX blockchain. So before registration, the device owner will also deploy a service smart contract, which will be used later on to serve other people. So anyone want to access my device data need to talk with this service contract. Also, device owner will get a temporary credential from the IoTeX account management service. So the device owner will use this temporary credential to directly upload the DID document to the AWS S3 bucket and get the corresponding URIs. With all this information in hand, the device owner will call another manufacturer smart contract to generate the DID. So the last step in our system will be the decentralized data authorization. So this involves the interactions between the device requester and device owner through the smart contract. So basically, the device requester will need to first check the what will behind the DID for this device. So in this figure, you can see the device owner will check the DID through a master smart contract, which will further call the manufacturer smart contract to retrieve the DID document. So this contract will tell the device requester where this DID document is retrieved. After retrieving the DID document, the data requester will see where is the service endpoint for the device. So in this case, will be the address of a service smart contract. So then the device requester will deposit the certain amount of cryptocurrency as well as specify the data they want to access. On the other hand, the device owner will monitor this service contract. Once they captured, okay, there's a request for this service. It's up to the device owner to decide whether they will grant or reject this service request. Once the service request is approved, the device owner will generate a token to the device requester, which will be used by the device requester to access the AWS S3 bucket to retrieve the data file. So you can see here we are involving a number of interactions with smart contract between the data requester and the data owner. So our implementation UI is like this. So we have the we have the web page. You can basically go over all the steps I explained before. We have the tracker here, how to generate the DID documents, how to resolve the DID, and request the tracker data. On the right side, you can see all the data collected from the tracker, like the GPS coordinates showing on the Google map, as well as temperature, humidity, as well as accelerator and the gyroscope. So this is just, I think, the first implementation to our knowledge to try to integrate the decentralized identifier and the verifiable credential into the lifetime of the IoT device, and to implement the decentralized data authorization within this ecosystem. Thanks for listening my presentation. If you have any questions regarding to this demo, please feel free to send me the email. Thank you.